Yes. Okay. So I think previous week I told you right I am not available.
Yes,
So I
yes,
think you
right.
joined.
No, no, not joined.
Yeah, I didn't send the link also, right?
Yes, right.
Okay. Let us start with this last module that is monitoring.
Okay. It will take 2 days only, sir, today and tomorrow.
No, no, no. Next week also.
Okay.
Next week is the last week. Okay.
Okay.
Maybe Saturday I will try to finish it or Sunday. If the program project is working, then that's fine.
Okay.
Okay. So what is meant by monitoring? I think we learned in DevOps the seven phases. Do you remember?
Yes.
Yes, sir. What are the seven phases of DevOps? I've uploaded the material also, right? You see that actually. First topic, introduction to DevOps is there. In that introduction to DevOps, file will be there. PDF. You are able to download that.
Planning, development, build, testing, release, deployment, monitoring.
Yes. So we are in the last phase. That is your monitoring. So all these days we learned about all the tools. I think you have written in your notebook also, na? Monitoring tools also. The
Yes.
same things here. So why we need monitoring actually? Is it monitoring necessary? What do you think?
Yes, necessary only.
That's what why?
For errors, if you want to see any error, like
Want to see.
CloudWatch is there in AWS. CloudWatch, it
Hmm.
will have a monitoring tool.
Hmm.
That means it will trigger whenever our budget exceeded. We can set up limits and everything.
Hmm.
So it is important to monitor.
Hmm. Hmm. Okay. So whenever the budget increases, one second factor, another thing. Any other factors are there? Any other factors are there? Why we need a monitoring tool?
No, no idea. You please continue.
Okay. So before we do something, before we want to take action, we need to know what is the exact status, right?
Yes,
So if already there is a more workload but the server is less, how will you know that? Or there should be some alert messages like, as you said, alert should come to us. The server is less, it is not able to manage the traffic, so we need to add one more instance, one more server. Or as I said, it will going beyond the budget or going beyond the storage limit what we set. So for all these things, like a monitoring tool is like continuous monitoring will be there, so that we'll be able to change anything we need to change it and make sure the process is running without having any issues. So for that we need this monitoring tools. Now, a robust monitoring strategy forms the backbone of successful DevOps. So DevOps, we have multiple tools. So we don't know what is happening or when which tool is having issues and all those things. All these things we can able to monitor in one tool. Similar to that, we have here we should have the visibility across all the entire technology stack. As DevOps is built based on technology stack. That means multiple stacks, multiple technologies are working together. So mainly it has to be work together properly. So enabling teams to maintain reliability while accelerating innovation. Accelerating innovation means we keep on adding still more and more tools also. So we should believe that, and we have to trust, and continuously we have to work with that. Now coming to this, what does monitoring in DevOps? Monitoring in DevOps involves the continuous tracking of system performance, availability, and health across your entire technology system. So as I told you, first one, how the system is performing, again what resources are available, and as is it ready for use, and what are the health across your entire technology ecosystem also there. So what is the health system? That means, I think you might have learned in your cloud practitioner, what are all the services will do the health checkup. Do you remember?
Yes.
Yes, what are all the services resources will check the health? Can you tell me what are the resources which will do the health checkup by itself in AWS? Do you remember?
Amazon Route S3,
Route 53,
CloudWatch,
Route 53, CloudWatch, okay.
Elastic Load Balancer,
Yes, Elastic Load Balancer,
Trusted Advisor,
okay. Trusted Advisor,
Health Dashboard,
yes. Health Dashboard, one more is there.
CloudWatch.
No, CloudWatch you already said. Next is auto scaling, okay. So all these things will be checking by default. It will check the health condition of your server, and Elastic Load Balancer will check whether it is a EC2 instance or IP address or container or Lambda also it will check. So same thing here, it provides the real time. This monitoring tools, what it will do, it is going to provide the real time visibility to the infrastructure metrics, and it will track your application's performance and the user experiences also. So mainly it will help you to enable proactive detection before issues impact the users. So we'll be able to monitor, since it is continuously monitored, we'll be able to know what is going to happen before the thing is going to impact the users. Next, we can able to create data-driven insights for continuous improvements. Creates data-driven insights for continuous improvement. Continuous improvement means we keep on improving, right? Our technologies, our development, everything will be keep on improving. So for that also, it will be giving you the insights. Insights means what? Yes, Kumar. Insights means what?
Understanding, analyzing data.
Yes, understanding or analyzing data. What is the outcome or what is the bottom line I can able to take it. Right. Same thing in the DevOps lifecycle where monitoring fits. So as you have already mentioned, the lifecycle we have first a plan. So planning mainly will have establish monitoring requirements and SLOs based on business needs. Next, development tools. So develop build instrumentation into applications from the start. So development phase. Then third, where we keep on activating your monitoring also. It is activated into the production phase. Then we have monitor. We will collect telemetry data and generate insights. Insights. One second. So next, yeah, telemetry data and generate insight. Telemetry metrics data it will collect and it will give you an insights based on that. Next, we can able to give use monitoring data to drive next iteration. That is what based on the feedback, what kind of thing we can able to do. That also able to plan according to the monitoring results. So this is just the phases of your DevOps, as we already know. In which phase this monitoring is coming? So monitoring is connected with everything also. Sometimes it monitoring is not a single phase but a continuous activity that empowers the entire DevOps feedback loop, driving improvements at each stage. So just now I told you, it is working on all the levels like development, testing, deployment, monitoring. Every phase it is working based on the feedback and get what insights we get. We can able to change the resources based on our requirement. Now, why monitoring is crucial? Why monitoring is crucial? So, enhance security posture. That is, we keep on continuous monitoring provides broad visibility across environments, helping teams identify inconsistency and potential security threats before they escalate it to the incident. So, as we already know, why we want to monitor, I think why we need security guy in an office.
Production.
Will
Security
you
means
put a security
production.
guy? Huh? No, no,
Like
security guy in an office, general office, general one physical office. You will put a security guy, right, for your office? Yes or no?
yes,
Why we want to put that security guy?
to check up our bags, monitor our bags, what we are taking inside and what we are taking from inside to outside.
No, no, I'm saying generally you think I'm not talking about okay he's going to check your bag. Leave that. I'm just saying you are keeping an office. Okay, you are having an office. In that office, will you put a security guy? Will you put a
You please
security
continue. No,
guy
no, no.
for
You
your
please
office?
continue.
You answer, man. You please continue. Please continue. If I keep on talking, it's like a monotonous talk, right? Whether you're understanding or not, I should know, right? You're doing something.
No, no, no.
Then what? I'm asking simple questions only, right? In your office, you're keeping an office. In your office, will you put a security guy?
Yes, yes.
Yes, that's what. For what purpose you will put?
For everything, to check the belongings, what people are coming, check the bags, everything, right?
Okay, not only that. Understand that. See, we are not putting a security. Let us say if we are not putting a security and someone has stolen something from your office, as you said, like not from the office workers, some other thieves are coming or some robbers are coming at night and stealing all these things. Correct. Now, once we put the security guy, after that, is there any use putting a security guy to an office after someone has stolen all the things? Is there any use? No. Correct. Yes or no?
Yes, correct.
So same thing, we want to know before something happen. For that we are connecting this monitoring tools. That's what you can see potential threats before they escalate to the instance, before something happens. Then later we should not regret that I could have put a security guy, he would have stopped this things. He would have stopped the robbers to by stealing it robbers not to steal it, right? Or he might have caught them at the right time. So all these things are matter. Same thing here also, the monitoring tools help us detecting the some issues before it is going to become a big instant. So next, early performance reduction. So monitoring tools is going to show you the performance of whether is there any performance issue is there. That means what your expectation is, the expectation met or not. If the expectation is not met, what we are going to do, that what step of actions we can able to take, that is also we can able to do it. So here it's like implementing monitoring and staging and testing environments, not just production alone. So testing itself we can able to check whether it is working or not. Like your they're like a motor pumps are there, right? So the motor pumps are tested before, correct? So they'll be testing it whether it is working fine, whether it will be able to take that much load or not. Only they will put a sticker like test okay. Next, visibility across complex systems. So with CI/CD pipelines, microservices, everything. So visibility monitoring tool, it's going to display the ratings, right? It is going to display the dashboard, or it's going to display about the ratings, metrics, and everything. Whatever we have configured, the visualization it is going to show. So by that, we'll be able to have a clear idea on what is happening. So that's why monitoring is crucial. Next, we'll go for types of monitoring. So here we have types of monitoring. One is infrastructure monitoring, next application monitoring, then user experience monitoring, log monitoring. And so as the name itself says that infrastructure monitoring means what? Whatever resources we are taking. So here there is again you can see that CPU, memory, disk IO, network traffic, cloud resource utilization. So these are all things will be coming for your EC2 instance, correct? So I can able to track monitoring the EC2 instance alone. Next, application monitoring, we can able to application monitoring means what? API. So API, how fast they are able to access, what kind of responses they are getting, and how much rate. You can see error rates, API latency, request volumes, dependencies, and transaction tracing also. So all these things we can able to see, track it on the application monitoring. This will capture the real user metrics. We can able to get how the page loads, how fast it is loading, how fast it is rendering to the next page, how is there any client side error. What is client side error? Which one is the client side error? Which one is client side? I think you know the three-tier architecture, correct? What is client side? Which one is client side?
It is from user side rather than server.
Yes, that's what user side means. Which one? Which one? Which one do you think?
Incorrect request,
No.
like
So
a
client side means what?
400 bad request, 401 unauthorized errors, like that.
Okay. So the client side is always your browser. First thing is your browser. If your browser, sometimes if you see some the website is not open, so we have to close the browser and open, or open in another browser. It might work. So it's called a client side error and interaction workflow. So how fast they are responding, how fast interaction is going. All these can be able to track and monitor. Next one, log monitoring. Log means what and all happened, what all things happened, who came, what he did, what he clicked, everything. So identify the patterns, errors, and anomalies through centralized collection. Anomalies means was like your this degree stages. This rating is then here. Like your ECG monitor, you have this lines right here. That's called your anomalies through centralized connection. So you can able to connect all these three things and see in the right side image you are able to see now. Similar to that, we can able to get the collection of all details in one page. Okay, you're writing this one, types of monitoring
No,
in your
I will
notebook.
refer the PDF.
Okay, you got the all the PDFs, right? Messaged. Yes. Okay. Next, real world example. So here you can able to see an e-commerce platform experiencing performance degradation during a holiday sales event. So what might be the issues? First, we have to check database connections is correct, API response time is increasing or not, and user card failures beginning. If there is any, I think sometimes you might have faced an issue that you keep on adding that into the add item into the cart, but it might not have added, or it might have added multiple times just one click. So these are all the common problems. So what will be the solution? So first one, early detection. First, with these problems, it's an e-commerce platform. So we as a developers, I mean not we, the developers will always think that what happen if this fails. So we have to go for always keep some plans. Same thing instead of that, not only instead of it should have a plan as well. But how can we early detect this? Mainly using this monitoring tool. So what monitoring tool can do? We can set some metrics like your CloudWatch metrics. We are going to set some metrics. Based on the metrics, it should trigger the mails. It could trigger the mails or it could send the notification. Next, database connection pool trends in identify. Database connection means how many people are accessing at the same time, how many people are posting their data into the database, whether database have any issues, that also we have to detect. On call engineer notified, so we can able to select like if something very high issue is there, some alert message is sent to their mobile through some alert signals. So this is just one an example. Shift resolution, now we have mentioned we have detected all these things, but what is the solution? So solution, maybe you can see the team responds with precise action based on monitoring data. That means based on the monitoring tool, we can able to, as a developer, can able to conclude conclusion what type of issue it is. So first one is if it's a database we can database is slow. Let us take this database is slow means what is the option we have? We can create read replicas. We can create read replicas to this database. So that's what database read replicas added. Next one, connection pool optimist. So if the API request call is very slow, how was the connection? Can we increase the connectivity? Next, cache hit ratio improve. What is by this cache hit? I hope you might have come across. Yes, okay. Do you know what is by cache hit?
No, no idea.
Okay, fine. So your browser, first time you go to a website, right? So it is loading. It is taking some time to load. But second time when you load to the same page, how is it fast or slow?
Fast.
Yes. Why? Why it is loading faster? Do you have any idea?
No idea.
Okay. So your data are already stored in the browser as cookies, correct? That's called a cache memory. So the cache memory is already stored with that website's content. Everything is already stored in your cache memory. So when you load to try to load the second time, it is automatically fetching faster. Now that's what this cache memory. That means if the data is already there and it is coming the second time, the cache is there, so that is cache hit. Now, if when you try to open a website and that cache is not there in here, that means in the cloud, then that means called cache miss. Okay, so the obviously the solution is what cache hit ratio should be improved so that all the websites will load faster. Next, early monitoring and early monitoring always. So monitoring is not nice to have. So it's a must in DevOps. So DevOps tools, monitoring is must because it empowers the teams to be a proactive, responsive, and resilient. Proactive, responsive, and resilient. I think resilient. I gave you the 13 points right in the first day. Okay, you guys are not. You are not there. Fine. So what is in the resilient? Do you have any idea?
To recover quickly from problems.
Yes, so recover from problems, fine, but you have to come back. You have to come back with the same question. So you have to come back with the same energy. That's what resilient. Now, what are the key takeaways we have taken from this slide? So we can integrate monitoring from day one in your development process. It covers all layers, infrastructure, application, and user experience also. Use monitoring insights mainly to drive continuous improvement. We can able to keep on improving by monitoring. Build a culture where data driven decisions are the norm. So data driven decision is based on the data we can come to a conclusion, not simply we can able to say like in a stock market and all. In stock market and all, people investing, right? How they investing? Without analyzing they'll invest?
No, they will take
No,
advices
right?
from
So
all the
that's what,
people.
yes, again they will also check the rating and everything, rate score, everything they will check. Based on that only they will invest. Now same thing only.
Wow. One small request. I got my food from order. I will collect and come. Okay.
Okay, okay, okay.
I am. I am back.
Okay. So access your current monitoring strategy and identify the gaps in visibility across your technology stacks. So we can able to monitor what is happening and everything. Based on the data, we can come to a conclusion also. Fine. Now we'll go for the tools of this monitoring. So first one, tools overview, Prometheus and Grafana. So we are going to see about the monitoring and visualization capacities for modern DevOps environments. Okay. Why these tools are necessary? So modern systems demand real-time monitoring. Real-time monitoring means nowadays the technology is like anything, any very high, correct? We can able to take decisions. They will try to put you, show you what is happening and everything. Even like Instagram marketing, metadata, Facebook marketing, social media marketing, all these things you might have noticed, uh, right? So how much data they have and how much easily they are giving us the solutions as well as the idea of what is happening. Now here you can able to see first one why these tools are necessary. So modern systems demand definitely real-time monitoring and clear visualization. So the left side image, first one you can see comprehensive monitoring. What? Comprehensive monitoring. Comprehensive means what? Comprehensive means what? Okay, let us say you are a staff in a
Complete.
company. You're an exec.
Complete.
Hmm?
Comprehensive means detailed covering.
Yes, detailed covering, but step by step, proper step by step comprehension. Now, same thing here. This Prometheus and Grafana provide this metrics collection and powerful time series based on modern DevOps environments. And Grafana, which is a visualization tool, so flexible visualization options will make complex infrastructure data accessible and actionable for teams of all size. For the all the teams of all the size, we can able to use it. It's not like only one. Then we have a strong community like the other tools. These tools also, Prometheus and Grafana, also have a strong community. Both the tools benefit from active open source community, ensuring continuous improvement and reliable support. Reliable support means we can able to continuously, you will get the support from this these two tools. So Prometheus is what? What is Prometheus? So Prometheus is a mainly a metrics-based monitoring tools. Mainly, it is an open source tool designed to collect and store the numeric metrics. So it is this Prometheus is mainly for collect collect and storing numerical metrics. What are the metrics? How much percentage you increase, the server increase, and all those things kind of thing. So Prometheus main job is collect and store. So you have to keep in mind Prometheus main job is what? Store and
Collect.
collect and store and keep it. Okay. Next, Grafana is for visualization. Grafana is for visualization. Now, this Prometheus will use to pull based architecture. Pull based means what? Something is there. I'm going to pull that and take it for me. So if I want, I only have to go and pull it. So it is actively scraps metrics endpoints rather than waiting for system. So it will not wait for the system to push it into the Prometheus. It will go and pull the data from wherever we have connected. So that's what systems to push data, ensuring reliability. Since it will be able to scrap the metrics means what? Since we have already configured it, whenever one data is come into the picture, immediately it will scrap. Immediately it will take all the data and it will add it in your metrics. Next, for this, Prometheus is using one more language called PromQL, like your SQL. I think you know SQL, right?
Yeah. Yes, yes,
Yes, structured query language. So query language is easy. Yes or no?
yes.
So same thing here. This powerful query language, which is PromQL, mainly it is designed for time series data analysis and manipulation. Time series means what? Every minute, for example, you want the data every minute or every 5 minutes or 10 minutes or every 1 hour or 6 hours, whatever it is, that we can able to create it, but that it will show it will just send the data in a time series format. So that's where your prom ql is helpful. Now, what are the Prometheus key features? First one, HTTP metric collection. HTTP metric collection means HTTP means nothing but your website collection. So it'll since it is using pull metrics via HTTP from the instrumented applications and exporters, making the integration straightforward. So here the exporters will be there, one of the other service. It will push the data to the account. That are the Prometheus. From Prometheus, it will go to some alert message or Grafana. It will go. So exporters, that is again one of the service which will help you to push the data to the Prometheus. Time series database. So what is this time series database? So your database, we can able to store the data in a timely basis, like every 5 minutes, every 10 minutes, every 20 minutes. I just now I told you it same thing with high write and query form. Query means, so okay, structure query is mainly for what purpose actually? SQL is for what purpose?
To write queries, to store that for storing data, retrieving data, updating
Yes,
data.
exactly. So to retrieve the data, right? Same thing here also. We are using this PromQL query to retrieve your data, which is already there as time series. Next, based on this time series, or you can set an alarm also. So we can define alert conditions and trigger notifications through alert manager when thresholds are exceeded. When thresholds are exceeded, threshold means we set some value like 50, 60, we have set some value. If it's going above that, we can able to get an alarm. Now what is Grafana? As I told you, Prometheus is for store and collect and store. Now Grafana is again an open source for data visualization. So we have data visualization tools. Apart from this, what are those the recent trend for the data science learners? Those are learning data science, they know, and you also will know. I think so. What are the business intelligent tools we have?
Power BI.
Exactly. So Power BI, Tableau, like that, we can able to create use this Grafana mainly for DevOps, where we are going to connect your data. So Grafana is again an open source visualization dashboard platform that transforms complex metric into intuitive visual representation. Like the left side image, we can able to have a visualization treat. So mainly it will work closely with Prometheus and many other data resources, and provides a it also provides a rich UI. So graphical user interface mainly for creating custom dashboards. Next, it enables at a glance understanding of systems health. So it can able to just understand about the health, and then only it will it will just denote us if whether the health condition is correct or not. Next, it support historical data analysis and real time monitoring. So mainly we want monitoring tool is for what? Real time metrics it has to show. That's why we want this tools. So obviously it will show that as well. Now, what are the key features of this Grafana? So mainly we can able to create interactive reusable dashboards also with drag and drop panels and diverse visualization options. That means we can able to create visualization dashboards like as you said, like Power BI, Tableau we can able to create. Next, multiple data also we can connect. So connect to Prometheus, Elasticsearch, Influx DB, many other data sources in a single dashboard. We can able to create it. Visual query builder. Visual query builder. Visual query builder means as just now we explained the SQL query. So what is the query? Query represents we want to get some results. So we are writing a query. Same thing if there is any complex queries are there, using using an UI you can able to, without knowing the language you want to create a visualization, then always go for Grafana, which will help you without needing to master your query languages we don't want to master at all. So by basic it will create it. Next, alerting system. We can able to set alarms based on the thresholds and receive the notifications also through various other channels like Slack or email. Slack or email is another. Slack is tool, and again email. That is, you want that message notifications to be to come for your email or Slack, any other option. Like we have this our channel is there, na? Our chat tool, Discord. So similar to Discord, Slack is one of the tool where we can able to get the notifications. So these are the key features. Now comparison between these two. So primary purpose here, the Prometheus, as I told you, it is collect and store the metrics. Here it is visualization metrics. Next, storage you can able to see. Here it is built in time series database we are creating. There it is no, we are not going to create database. So is only we are going to create visualization. We are not going to done anything. Via alert message we can able to create alert message in Prometheus also and Grafana also. So built in time series DB none. Here it is visualization is none. Next, perfect complementary tools. It is saying that we can able to use these tools, that is Prometheus and Grafana, which is a perfect complementary tool mainly for your data collection and visualization. So Prometheus excels the data collection while Grafana transforms the data into actionable insights. Mainly why we want to use this Power BI table. We want to know about the insights, what we can do and what we don't want to do. Same thing here. Next to DevOps standards. So these two tools has become the de facto standard for cloud native monitoring and observability also. So that is mostly when those who are using the cloud platforms, they will can definitely use go with Prometheus and Grafana for the monitoring tools instead of going for other tools. Again, start small, scale up. So begin with basic metrics and gradually expand your monitoring capabilities as a need grows. So this is just a start small, scale up. So we can able to start as a small, and but we can able to increase these capabilities later also. So mainly why we need this Prometheus and Grafana, mainly for monitoring, because this will collect and store the data, and Grafana will show us a visualization tool. And these two tools will be in up to the standard of DevOps tools, and later we can able to increase or decrease also. These are the major factors why we want to know this. Okay, so we have done the introduction to monitoring tools. Now we'll go for Prometheus. Now we'll see about Prometheus alone. Okay. Prometheus and Grafana we'll see in depth. So as just now I explained you what is Prometheus. Prometheus is an open source. We can able to call this as an alerting toolkit. Mainly it is having a toolkit which is designed for reliability and scalability in the modern infrastructure environment. So it was first developed by SoundCloud, and it has become a part of your DevOps tools mainly for metrics collection and cloud native ecosystem we want to create. We can go with Prometheus. What are the things it will do? It will collect the time series data using pull based model. Okay. Now you remember what is time series data? Yes. You remember time series data? What is mean by that?
Yes, CPU usage, memory usage, network traffic,
No, no, no. The usage is fine, but time series. Why we say that time series? It
data
is
collected
history.
and recorded at different points of time, usually at regular intervals,
Exactly.
like 25 degrees centigrade, temperature at
Yes, yes. The timings which we are setting based on what data you are collecting. Okay. Next, features prompt QL. So we already know that prompt QL, I explained here, it's a powerful flexible query language, mainly emphasizes reliability through simple architecture. We can able to rely on this Prometheus also, and it operates autonomously without complex dependencies. So it's not necessary that I have to install this, that, and all those things to run this Prometheus. It will normally run like any other servers. Now here you can see the architecture of Prometheus. So this is the batch workload. It will push into gateway, the push gateway metrics. From there, it is taken to exporters. From exporters, it will go to your Prometheus server. From Prometheus server, the metrics are decided. So here you can able to see first the data will come to the exporters. From the exporters, it will be as Prometheus is going to take the pull method. So it is going to pull this from this exporters, and it will take and pass it as TSDB. What is TSDB? Just now I told you. Time series database. What? Time series database it will check. And whether I want to pass this data to any other next level of resources like Kubernetes or service discovery, or I have to send an alert message. I have to send an alert message to the user through email or Slack or anything. Then, if you are taking your data for visualization, then we'll be connecting that with your Grafana. That's what this one. I'm not having this marker option here. Now let us see what are these things. So Prometheus, as we just now told you, it's a central component which is scraps and stores time series. Scraps means what? It'll start from the beginning. It'll start from the beginning wherever it starts from. It'll start from that. Next to time series database. Mainly it'll collect and store, it'll custom build storage for efficient querying for time-based metric. That means just now I told you the time series, it'll give you a time-based series of data which is stored in the database. Next PromQL engine. So that's one of the query language that process enables your complex data analysis process. We need this query language, that is your PromQL. And exporters, what this exporters is doing? Exporters is mainly converting your existing metrics from services into Prometheus format. It will convert and keep it ready so that Prometheus will pull the data from the exporters. Then alert managers, it will handle all the alerts from the Prometheus server, including reduplication, grouping, and routing also. So whether if you're reduplicating or grouping or routing, whatever it is, we can able to send an alert message. Service discovery, mainly it will identify the targets in the cloud environment. So it will go and check what are all the services running, that it will check, or if you're mentioning some service, it will help you to reach out to that server. That's what your service discovery. So all these are optional only, this service discovery and this one. Alert message, yes, if you are setting something, you can able to set your alert message. Now, why choose Prometheus? So why we need to choose Prometheus? Prometheus is cloud native architecture. It is mainly used for cloud native architecture. Cloud native means what? What do you think cloud native?
Applications designing, software build for the cloud purpose, like automation scalability.
Yes, cloud native means nothing but Prometheus can able to support in multiple clouds also. It will work with all the cloud supporting tools. So you can see it can able to work with environments like Kubernetes, Docker, right? AWS, GCP, Azure, everywhere it will work. So that's why cloud native architecture. Why we want to choose this, and it will be having inference infrastructure. Inference means temporary infrastructure also will be there, where all the services will come and go frequently as well. It is lightweight deployment. Lightweight deployment means single binary installation. We can able to install in one shot. We can able to install with minimal dependencies and makes your Prometheus exceptionally easy to deploy and maintain also. So it will reduce the operational overhead for DevOps teams as well. Powerful integration seamlessly works with Grafana mainly for visualization also, and it will go for alert manager, notifications, or various other services or any other mechanism which we are creating. It will also support that, and it will help for a complete monitoring thing. So Prometheus is, as I told you, it will not only support AWS, it will support multi-cloud also. It's a cloud native and it will support. So as I told you earlier, there are Kubernetes also, it's a big giant. So Kubernetes also it will support. Now what are the use cases? When and all we need this Prometheus is mainly. So mainly system monitoring, because we have to keep on monitoring. So track essential infrastructure metrics, and including which is include because system monitoring means as usual. I think you also said right same thing. CPU monitoring, memory, disk, network traffic, everything we can able to check it using Prometheus. Next, application performance, as we saw in the monitoring types of monitoring, you can able to see your application's performance. So how the application is performing, how the request rates are increased or down, how many errors are there, all these things we can able to check it mainly of your application's health and maintenance you can able to check. Next, Kubernetes insights, yes, it will support Kubernetes also. It will gain visibility into pod resource usage, node health checkup, service availability, and cluster wide metrics from comprehensive container orchestration monitoring tools we can able to check. So just now it only easy to, it's not only easy to ES3, you can able to get the insights through Prometheus for Kubernetes as well. Next one, business metrics. So we can able to track custom business specific metrics like orders processed per second, how many orders per second processed per second, how many user signups or transaction volumes, to align technical performance with business objectives also. So all these things we can able to get it through your Prometheus. These are the use cases. So we can get business metrics, Kubernetes insight, action performance, and system monitoring. Setting up Prometheus. How to set Prometheus? So for a robust scaling monitoring deployment, Prometheus with an elastic Kubernetes. So we combine with EKS. Why EKS? Because that will be the best common approach where with Kubernetes you will be able to have a monitor pod, you will be able to monitor the node and everything as well. As this setup will leverage Kubernetes orchestration capabilities mainly for managing Prometheus and its components also. So how we are going to do is we are going to do with EKS cluster. Initialize your Kubernetes environment using EKS CTL, setting up the cluster and worker nodes, and this step establishes the foundation for your monitoring. So you can able to see EKS CTL create cluster name is equal to monitoring and region is AP South 1. That is one. Next, install Cube Prometheus stack. So how we are going to install Prometheus stack? Mainly with the Helm tool. We learned about Helm tool previously. Do you remember?
Yes.
Yes. So that tool is for what? That's a package management tool. Okay. So that Helm also helps the Kubernetes package management manager to deploy all the Cube Prometheus stack. This will include all the Prometheus, Grafana, Alert Manager, pre-configure, and Kubernetes for Kubernetes as well. So that you can able to see here. Helm install monitoring Prometheus community. Next, to deploy the chart into a new namespace monitoring. So kubectl create namespace monitoring. Next, we are installing this Helm using installing this Prometheus. We are installing. Next, to check the output, we have to check whether get all -n monitoring. So it will confirm all the components are running correctly and accessing the Prometheus and other things also. We can able to forward. We have to forward the port. That means we have to connect the port. So port forwarding to begin querying metrics and visualize data. We have to see here 9090 is that port we have to define. Like all these days, we might have defined for I think Jenkins. What is the port number? Do you remember? For Jenkins, what is the port number? Do you remember?
8080.
Yes, same thing here. We are going to define the port. So for that port, the monitoring tool we can able to forward, and from there we can able to access the monitoring tool, that is your Prometheus. Now clean up to uninstall all these things. What you as usual, like in your Terraform and all, you have done like Terraform uninstall, Terraform destroy. Same thing here. Helm uninstall monitoring namespace monitoring. So it will remove all the deployed resources as well, and you can EKS cluster also will not be needed. So it will make sure all the data are cleaned and cost effective exit setup from the setup. So this process streamlines all the deployment of a full-fledged monitoring system, integrating seamlessly with your cloud native applications. Scrapping metrics. Scrapping means what? From the base, it will start scrapping. From the base, it will start from scrapping. That is, it will pull all the data from the beginning. I think in your WhatsApp will do right when you uninstall and install or restore backup. What it will happen?
Automatically, all our charts will come.
Yes, it will get restored. Correct, na? So
Correct.
whenever you are changing your mobile, also you install a new mobile, automatically that messages and all will start from the beginning wherever you left, or how long back you have done. Most of the data will be there. Same thing only. Scrap metering is it is going to pull the data, as we already mentioned that Prometheus is going to pull the data. Now this pulling data will take all the data from the scrap. That's what scrapping metrics. So it's centralized control of scrap frequency and timeout settings. How far we have to scrap, what is the time limit, the time frequency we can mention. Better resilience against the thundering head problems. Resilience, just now I told you. If anything happens, it has to come back to its original position. You can easily debug and check the access the metrics points. And metrics are available even when Prometheus is temporarily down also. So that is one of the major plus point. Each target exposes a matrix slash endpoint. That means whatever the target resource you are taking, there you have to put slash matrix and what is the endpoint in a standardized text format that Prometheus scraps at configurable intervals, typically 15 to 30 seconds. It will be working. So Prometheus in practice. So key strength. What are the key strength and next steps? So what are the key strengths we have found this year? So dimensional data model with powerful querying. No reliance on distributed storage. No reliance on distributed storage means no need of rely on the distributed storage. Operational simplicity for DevOps teams. Operational simplicity for DevOps teams. That is, we can able to keep on easily check what has happened and everything. Designed for reliability in unstable environments. Mainly designed for reliability in unstable environments. So even if, as just now we learned, Prometheus will keep on adding the data, even it can able to withstand for degradation as well. Temporarily down also we can able to use it. What are the next steps? So we have to set up once Prometheus is set up, then we have to set up Grafana for enhanced visualization. We can configure alerts mainly based on metrics threshold and implement custom exporters for specialized metrics as well. Scale with federation for larger deployments also. So all these things we can able to do it. Okay, next one we'll go with Grafana. Now Grafana, as we already mentioned, that Grafana is a visualization tool. So this visualization metrics, all through everything we need to know to start visualizing your metrics. Okay, first one, what is Grafana? So Grafana again, it's also an open source platform mainly for visualization and analyzing your metrics from various data. So it's like a visualization tool, like I think you might have learned Redshift, Amazon Redshift.
Yes,
It's
yes,
cloud practitioner, correct? Na? Yes, Redshift, with that,
correct.
what we can do? Redshift is a data warehouse, correct? So data warehouse, we store all the data, but Redshift will help you for a graph, like dashboard creation. Also, it will support. Same thing only here. This Grafana is a tool which will take all the data from various resources. Also, mainly originally built for time series data. Time series every time to time. So here the graph you can able to see time by time space. It has evolved into a comprehensive monitoring solution that supports real-time monitoring dashboard with interactive visualization, multi-dimensional metric analysis and correlation, sophisticated alerting mechanism with multiple notification channels. So mainly it will monitor, it will be showing the real-time monitoring dashboard. Mainly it will be some lot of visualization. You can have multi-dimensional metric analysis and correlation also. Sophisticated alert mechanism. If you have set any alert mechanism, you can do that with multiple notifications and role-based access control for enterprise deployments also. So role-based control also we can able to give it. Next, why choose Grafana? Mainly, the data collection was already done by Prometheus. Prometheus grabs and store all the metrics from the configured targets in real time series database, providing a powerful foundation for monitoring. Grafana, what will do? Grafana now will take all the raw data that was taken by Prometheus into interactive real-time dashboards with the drag and drop interface for rapid graph creation also. And action will set the thresholds, creates alerts, and respond to incidents faster and response to incidents faster also with customizable notification channels and escalations policies. That means slow. So when we set some alerts messages, it'll keep on responding as well. If it's responding instance, it'll keep on acting on that as well. So Grafana's intuitive interface mainly allows technical and non-technical users like create meaningful visualizations without writing code. So while still offering advanced capabilities for power users. So it will also help you to not only those who know. See why we people want to learn DevOps mainly. Why people chose DevOps.
It is a trending tool.
No, because codingless, correct? Now those who don't want to code, they might have a thought, I don't want like coding and all. I want something drag and drop. I want to just click connect. That's it.
Yes,
Correct. That's what the
correct.
mindset. Yes. So same thing only here also. That's what we are also going to do. See, technical or non-technical, whatever it is, it will give you the right code. It will going to fetch the data from the data which is collected already by the other two, and it's going to display. We don't want to have any technical skill sets also. We can able to see it. Now see here the DevOps dashboard how it does look like. Next again Kubernetes monitoring, business dashboards we can create, advanced alerting system also we can create using this Grafana. So DevOps dashboard, we definitely monitor your CPU utilization, memory consumption, and disk IO, network traffic across all their entire fleet. Fleet means number of servers. Next, it will also help you in Kubernetes monitoring also, track cluster health, pod status, deployment success rates, and resource utilization across namespace and workloads also. Business dashboards visualize KPIs including sales, performance, conversion rates, user engagement metrics, and business process efficiently. So it will also give you, you can able to also use this Grafana for other business dashboards like sales dashboard, this dashboard, business dashboards, profit and loss dashboard, like that also we can use, or like DevOps tools and Kubernetes monitoring. So Kubernetes, as just now I told you, pod status, node status, cluster status, all these things we can see. Apart from that, we can able to set advanced alerting configurations also, configure multi condition alert rules with sophisticated notification routing to email, Slack, page duty, and custom webhooks. So, uh, Web hooks means one tool to another tool, the connectivity between one tool to another tool. That's what your web hooks. So these are the use cases of Grafana. Now, same thing from connecting, how we are going to connect this Prometheus as a data source. So navigate to configure data sources into the Grafana sidebar. You have to click add a data source and select Prometheus on the list. First one you can able to see left side. Navigate to configuration data source into Grafana sidebar. Click add a data source and select Prometheus from the list. Enter the Prometheus URL like localhost 1990, and just for our environment we have to copy paste that port number and the link. Then it will configure the scrap interviews. That is how far how much seconds interval you want the data to be updated every 15 seconds or 20 seconds or 30 seconds. The frequency we have to mention, and then set up the query timeout, how much time we can able to set. HTTP methods also, what HTTP methods you want, that also. And enable or disable the metrics caching the based on performance requirements. Next, click save and test to verify the connection also. So a successful connection will display a green data source is working message. So it will show you a green message. You see data source is working. Like that it will show, and that's your image stack flow. Okay. Next, querying and creating visual using prompt QL. So without effect, writing effective prompt QL queries will display the particular visualization. So promptly support the functions for rates, sums, average, percentage, and predictions with the syntaxes like we can able to see what I want. Visualization means what a visualization I want. I want only the rate when. So total request every 5 minutes. Next, I want the rate status 500. That is for 6 successful requests. Successful requests alone I want to do every 5 minutes. Or creating another complex visualization with some metrics and insights which will give you more insights like graphs, charges, heat maps, tables, stats, everything we can able to configure. Custom access range. Access range means your x-axis and y-axis. You can define that. You can define the units and decimal precisions as well. Custom access range, units and decimal precisions, and color thresholds based on metrics values also. So we can able to create the Grafana using your prompt queries, only one particular access also, or full visualization also we can create based on what we want, what metric we want. Now, what are the key takeaways here we have? So enhanced visualization, Grafana offers intuitive interactive dashboards for real-time data explorations, powerful monitoring also. Prometheus provides robust time series data collections with flexible prompt QL and actionable insights. Together, they enable comprehensive monitoring, alerting, and rapid incident response. So, incident response is what happens. Something happens, how I'm going to respond. Visualization, as just now I told you, intuitive, interactive dashboards we can able to create with real-time data. Monitoring, robust time series data collection with flexible prompt kill from the Prometheus we can able to do. And from that database, from that insight, from that design and graph, we can able to understand, get some insights where daily they'll display the monitoring alert and any other responses. Next is scalable and open source. As both the platforms are open source, it is highly customizable and scale for diverse needs as well. Okay, so we have done with this Prometheus and Grafana. We have to practical. If we go now, it will be a Kubernetes cluster. It will go. It will take some more time. So what we'll do, we will um, we will finish the other monitoring tool, that is AWS CloudWatch. Also, we'll finish it, the theory part, and tomorrow we will start directly with the practical. Is that fine?
Okay, fine.
Okay, because it will take more time. Okay, fine. So now I'll start with introduction to monitoring on AWS. Okay.
Okay.
Yes. So I just now completed the Prometheus and Grafana. Now we'll talk about monitoring on AWS. How this same kind of monitoring tool, which AWS already has, that is your CloudWatch. Yes, Suryans, you are able to hear me?
Yes, yes, I can able to hear you.
Okay, fine. Now we'll go for monitoring on cloud with AWS CloudWatch. So same thing, CloudWatch, as the name itself says, watching the cloud. So this will also give you a real-time visibility into your AWS infrastructure, applications and services as well. It will also collect the track metrics, logs and events across your AWS resources. We can able to track all our resources like EC2, ES3 bucket, and other tools, also RDS and all those things. We can also set up automatic alerts, and we can take the actions whenever some threshold is exceeded. Thresholds are getting exceeded. We can gain operational insights to optimize performance and resource utilization also. So mainly why we want to have this tool is mainly to optimize the performance. Correct? Optimize means to enhance the performance and enhance the utilization, resource utilization also. So now why this monitoring important on cloud? So as just now we discussed same thing only. It'll have real-time tracking. Cloud resources are dynamic and ephemeral. Ephemeral means what? Temporary sometimes. So requiring continuous monitoring to understand their state, behavior, and performance characteristics in the real time. So we'll be able to track it, and we can able to take the correct step of actions. And mainly why we need monitoring, again, early issue deductions. If something is going to happen in the future or tomorrow or today evening or something, whatever it is, we can able to identify before itself. So identify problems before they affect users by spotting anomalies, performance degradation and resource constraints that could lead to outages or poor user experience also. So identify the problems before they affect users by spotting anomalies, performance degradation. Performance degradation means what? So if you get the performance going to down, anomalies means, as I already told you, like the ECG machine, you'll have this ratings. Once it reaches, it'll automatically go for this one. And resource constraints that could lead to outages or poor user experience. So it might lead to poor user experience as something is not working. Next, operational support. So it enables critical operational functions, including automatic scaling based on demand. Operational support, because operational people only going to keep on monitoring all these things. So they it's going to provide an automatic support, proactive alerting. Something is going to happen means it's proactively alerting us. Okay, this is what going to happen. We are in need of server. We are having in need of lot of storage. All those things for immediate response and detailed cost control mechanism. So why we want to monitor this one? Mainly to cost control, correct? So that we can avoid some unusual or unexpected things which is going to happen. That we can able to avoid. Next, introduction to AWS CloudWatch. So AWS natives monitoring solution. So by default, AWS has defined this CloudWatch tool. Just now we learned about Prometheus, right, and Grafana. Same thing here. This CloudWatch is having both. Will collect the metrics. That is what it is. Collect the metrics, gather metrics, logs, events from all the AWS services and the custom applications as well. It will itself collect, it will itself analyze, it will self analyze, process data for insights through statistical analysis and pattern recognition also. Pattern recognition is based on what pattern it is working, that pattern, and act. So it is going to give you want a visualization, then I'll give you a visualization. That also it can do. You want alert message, I'll give you alert message. Automated response also based on defined conditions. Based on defined conditions, we can able to use this. That means what is the condition that we have to mention. That's a threshold value like that we have to mention it. That's what I think you can able to see in the left side, right? CloudWatch, metrics, alarm, logs, dashboard, events. So CloudWatch is mainly doing both the work of Prometheus and Grafana, that is collect, analyze, and act on visualization. Also, it will do visualization. Also, it will do. 1 minute. Okay. Okay. So, what are the key features? What are the key features of AWS CloudWatch? So CloudWatch again, you are able to see in the left side, right? So it will show the monitoring visualization tools as well.
Yes, right.
Metric monitoring. It will show the metrics also. What is the metrics? So pre-configured metrics for AWS services, custom metrics for application specific monitoring. So applications particularly I want to mention only API transactions or server or storage that we can mention. High resolution metrics like down to 1 second granularity also we can check. Supports multiple dimensions for detailed analysis. Multiple dimensions for multiple means same resource tracking in multiple dimensions. That is, for example, if you take RDS, I want to know how much space it is taking, how much instance, how much server space is, how much server it is running. All these things for same thing also we can able to go for different angles. I think you might have checked in when you click EC2 monitoring will be there when you are launched your servers. There below itself you'll be able to see lot of dashboards will be there. So by default, it is collecting whichever we want. We can create a specific dashboard with specific metrics also. That's what custom metrics we can able to create it. And even it can go up to 1 second granularity. 1 second granularity means what? Every 1 second the data is getting generated like a track, like as I told you, right? This on the left side diagram is one, the ECG lines, the anomaly detection can be done. So one is metrics monitoring. We can put metrics based on metrics. We can put visualization. Another one is log monitoring. That is who came, what he did, what storage he did, what and all things he changed. Everything will be tracked. So centralized log storage and analysis, real-time log processing, log insights for pattern searching, log insights for pattern searching. That is login means who came, what he did, and all those things. Pattern searching, what kind of things he searched, and all those things. Filtering and subscription options also. We can able to put filters also in the logs. Next, we can create alarms and events. As we just now I told you, alarms also we can set. If our utilization is more than 60%, I think in your high availability lab we have done this already. If more than 60% is there, we can able to set an alarms. So threshold based alerting, anomaly detection capabilities if it is reaching a particular level. Next, integration with SNS for notification. SNS is simple notification service. You can send it as a mail, correct na? It will be sending as a mail. Next, automatic remediation with Lambda. Lambda, why? Because Lambda is a 15 minutes process, right? It will work only for 15 minutes. If immediate action you want to take, you can set through Lambda also. Next one, dashboard, customizable visualization panels, cross region and cross account views. So cross region, you can able to create a dashboard across region as well. Cross account also you can able to create, and shareable dashboard. So once you create here, you can share that dashboard to somebody else also. So that is also possible. I mean, somebody else is in your team members from the other account, other place also you can able to share it. Live data refreshing. So once you set the metrics, automatically it will refresh the data every seconds or minutes, whatever you are setting. Next, CloudWatch use case. So where and all you will use case. Mainly first one EC2 instance for mainly for monitoring your CPU utilization, network traffic, disk IO performance, input output performance to optimize instant types and ensure applications performance also. So it will give you applications performance as well. Next, Lambda function analysis. It will monitor invocation counts. Lambda function also same thing because both are compute service. Na? Both you can able to count and duration. Yes, Lambda just now I told you. Lambda is for 15 minutes. So how much duration I am using Lambda? What are the error rates? Throttling events to fine tune memory allocation. Anything mainly to fine tune memory allocation and concurrency settings. So how much memory we need. I think in the labs you might have done Lambda lab. If you have done, you will be able to understand that in the educate. Next one, cost threshold alert. So if alert budgets you are setting billing alerts to notify whenever the AWS costs exceed predefined threshold values, preventing unexpected charges and budget overruns. If the budget is overrunning, we can able to set that. RDS performance tracking, visualize database connections, query performance, and storage utilization mainly to identify bottlenecks and optimize database configurations. So RDS just now I gave an example, right? So it will come under storage also, it will come under database connection also, it will coming under your EC2 also. So storage utilization, database connections, API, how we are tracking all these things. So all these things we can able to do it with CloudWatch. Final takeaways. So what are the key takeaways from this slide? So cloud monitoring is essential mainly. So complete visibility we can get. So gain comprehensive insight into every layer of your cloud infrastructure, from hardware level metrics to application performance, enhance reliability, intelligent scaling. So we can able to complete visibility of all your resources and its insights we can get. Reliability, that means we can detect and address issues before they impact the users, maintain high availability meeting the SLAs, service level agreements. Then intelligent scaling, make data driven decisions about resource allocations, enabling precise automatic scaling based on actual usage patterns. Also, we can able to do it. So start implementing CloudWatch monitoring for your infrastructure today to gain. Fine. That we'll say now. This is one. Next we'll see. mm, CloudWatch metrics and alarms. CloudWatch metrics and alarms. So, as we already know that it's going to give you metrics and alarms, real-time monitoring and proactive alerting. Proactive means what? Before something happen, I am understanding that it's going to happen. So, what are the necessary steps I have to take? So, we will explore how these powerful monitoring tools work together, mainly to provide visibility into your AWS resources and enable automated responses to changing conditions also. So let us see what are the CloudWatch metrics. So here you can able to see CloudWatch or metrics are the real time order data. Like in the Prometheus, we just learned about TSDB. What is this TSDB?
Time series database.
Yes, exactly. So time series database, same thing here also. It is time order data points that provide visibility into your AWS resources and applications. So they form the foundation, that is CloudWatch monitoring. Automatic collection, as by default, since it is already in AWS, by default it is collecting. So AWS automatically collects standard metrics like CPU utilization, networking, disk read operations, write operations, and supports all the services without any additional configurations. Next, custom metrics. Beyond standard metrics, you can publish custom application metrics using the AWS SDK or CloudWatch agent to monitor business specific data points also. So it will go to take the metrics. We can able to customize it also. Structured data. So each metric contains metadata. Metadata means your data about data, which will include all your namespace, service level identifiers, dimensions, everything like unit of measures, timestamp, everything. So how we are going to order all these things? Whether we are going to keep it in like JSON format, if you keep, it will be like key value pairs. But we want this like a table like structure. So that's why we use for this. It'll create a table like structure only. So anyway, that depends on what are the metrics we are selecting. Based on that, it will create your dashboards also and metrics table as well. See, just now I told you like this metrics table. So one column instance ID, one column metrics name, one column alert. Like that, it will be showing a table like structure. Common metrics we can able to select by service. Service means you see lot of services are here. You can able to see here CPU credit balance, CPU utilization. I want to select CPU utilization for which server I want to track. All those things specifically also we can go. So each services will expose specific metrics that reflects its operational characteristics only. So CPU utilization is one, network output, disk read bytes, network in, and all those things. Understanding these key metrics is essential for effective monitoring. So what are the key metrics you can see? In EC2, what we can monitor? In EC2, we can monitor CPU utilization, disk read and write. What they will tell you? They will server performance, how is the server's performance, how the resource constraints, what is the network traffic. Lambda, you can see invocations, duration, errors, and throttles. So these are the key metrics which we need to monitor. It will say about the how was the function usage, what is the execution time, what is the failure rates, concurrency limits. Concurrent means what? At the same time. Next, RDS, CPU utilization, free storage, space, database connections, database load, storage capacity, connection saturations. So CPU utilization, RDS means CPU utilization because it's a server again. Again, it needs storage. So how much pure storage is connected? Storage space is there. Then database connections. How much database connections are there? How many people are requested? All those things. Next, S3, number of objects, bucket size, bytes. So S3 now, how many number of objects are there? How many number of what is the size of the objects? So whether the storage will growth, object count will increase, or what is the errors which is happening. So these are the things which is going to tell. We are going to get these are the insights which we are going to get from these services. Next, what are CloudWatch alarms? So how to create alarms? So here you can able to see. I think if you have done this high availability lab, you might need that. In alarm, it will show in alarm because we have set some threshold value of CPU utilization. So if the CPU utilization is above 60% for more than 5 minutes, it will automatically add one more instance. But before that, it is have to show to us that in alarm stage. So here the definition you see. So CloudWatch alarms continuously evaluate metrics against thresholds that we define, you define, triggering automatic notifications or actions when conditions are met. So they transform passive monitoring into active response systems. Passive response means passive monitoring into active response systems as well. That is, it actively monitoring and doing, taking the actions, possible actions. What are the actions are possible? So in alarms we can set like send notification via SMS or execute auto scaling policy. What action we want to take? That's what it's saying. Or stop or terminate or reboot or recover EC2 instance or trigger a lambda function. These are the actions which we can able to take it. Alarm states, there are some three alarm states. One is okay, that is your metrics is going fine, nothing is the issue. That means after defining the metric, for example 60% is the CPU utilization, at that time normally it is going, it is not exceeded that limit, means it will go okay. Next alarm means it has exceeded the limit, that means it's above 60% more than 5 minutes. Now metrics has reached the threshold for threshold value, so it will show in alarm stage. Next state is insufficient data. That means still the server itself not loaded or the alarm is still not ready. Or not, that's what not enough data to evaluate alarm condition. These are the three states. Now how to create alarm is the steps. So choose a metrics. First to choose a metric, select from available metrics across services or custom metrics which we are publishing. Filter by namespace, dimension or search by name to find relevant metrics. Next set threshold conditions. Define when your alarm should trigger, greater than or less than or equal to a specific value. Configure evaluation periods and data points to alarms. So just now I told you, so we can set the CPU utilization more than 60% for 3 out of 5 periods, 3 out of 5, 5 minutes or 5 periods. We can specify greater than or equal to. Then once this reaches above 80% for 3 minutes or 5 minutes, we can able to see that what kind of action. So here you can see SNS notification, auto scaling, or easy to action, or system manager configuration. So what action I want to take, that we have to mention. Then review it before you submit the settings. Review your alarm, add a description, review the configuration, and create best practice. Use descriptive names that indicate the resource and condition being monitored also. So before we have before we set we before we submit that alarm, we first check whether everything is correct, and then we have to submit it. And description again, see, simply setting alarm won't be good. You have to write a description for that, for what purpose is this alarm, so that next time again someone is watching or someone is doing, or you yourself have to remember, means you will be easy for it will be easy for you. Okay, so
Okay.
that's what this. Next, recap. So metrics plus alarm. So we saw about metrics plus alarm in this slide, which is equal to nothing but smart monitoring. So because it's going to take the metrics and we are going to set alarms, by default AWS is collecting the metrics as well. Now provide metrics visibility, collects and visualize performance data across AWS infrastructure and applications, and establishing baselines and identify trends. Alarms enable reactions, so to transform all the passive data into actionable insights by setting thresholds that trigger notification and automated responses. Proactive management, so anticipate and address issues before they impact the users. So scale resources dynamically to match demand patterns and optimize the cost. So we can able to scale the demand, sorry, we can able to match the demand patterns and optimize the cost also, because before something happen, we know proactively what action we have to take, because we already got the alert message also, what kind of action we might have already set. So monitor smart, act fast. Next, Monitoring EC2 S3 custom metrics with AWS CloudWatch. It's not changed. Is the slide changed?
No,
You
not
guys-
change. End of the slide.
Okay, right. It's not showing anything. So, 1 minute. It is showing here as selected but not visible for you. 1 minute. Hmm. Yeah, now it's visible. Monitoring EC2 S3 custom metrics with CloudWatch.
Yes, visible.
Okay. So this will explore about how effectively monitoring on EC2 S3 and implement custom metrics on this. So monitoring EC2 with CloudWatch. So here you can see the setup here. We have to click the dashboard. You see metric name, what metric we are going to assign, and what is the instant ID. It will going to individually monitor the instance also. We'll be setting, and here the static threshold value. I think in the cloud practitioner when I teach you the slide will be there in that CloudWatch metric will be there. There you can might have seen the static threshold. That is static means average sum like that we can select. Period is every 1 minute or 3 minute of I mean just now I showed you right previous slide. What is the period time? Now what CloudWatch will do? CloudWatch will provide the comprehensive monitoring of EC2 instance with built-in metrics that we can track it. Mainly CPU utilization across all the cores, all the disk read and write operations and throughput, network traffic also in and out, packlet counts as well, and status checks so that the system level and instant level are there. I think when you launch your EC2 instance, you'll be able to see the status now. 3 by 3 check passed or 2
Yes,
by 2 check passed. Yes. So that is one is in system level, one is instant level. Next, set up proactive alarms. We can able to set up alarms also notification and automate actions when thresholds are exceeded. So what are the common alarm configurations include? So for CPU utilization is greater than 80% for 5 minutes. We are setting an alarm configuration. Next, data check failures. If the failure is greater than one, immediately I want to send a notification. That is another one. Another thing is memory utilization. If the memory is utilized more than 90%, then I have to be take some action. For that, we have to set up everything. Then it will automatically send your email. Now, for deeper visibility, if still you want to go more in-depth data, what is that? What is that? What is it? Like your task manager, in-depth things will be there. Same thing you want, then you have to deploy this CloudWatch agent to collect the memory utilization, disk space users, process level metrics, and aren't that not are that are not available by default. Default something is not there. You can deploy this CloudWatch agent as well. Next, monitoring S3 bucket. Monitoring S3 bucket. S3 bucket is storage. As we know that we can track the bucket growth with the bucket size or bytes. So, what is the size of your objects? Metrics to monitor storage, cost, and capacity planning. Also, use number of objects to observe object count trends and optimize lifecycle policies. Request metrics. So, monitor all requests, get requests, and put requests to understand access patterns. So enable request metrics at the bucket level or filter by prefix for detailed analysis. For detailed analysis, we can able to get that. So we can mean what are the request came, how many get request came, how many put request came. Because it's about the storage, right? So how many people come to access it. Next, what are the error messages? So 4x errors, that is client side error or server side error, that is 5x error. 4x error means 404, 403 like that. Server side error is always 5, 503, 501, 500 like that. So to quickly identify the access problems, set up alarms for unusual errors, rate spikes that may indicate configuration issues or attacks also. S3 metrics mainly are delivered at 1 minute interval and retained for 15 months. So we know that the CloudWatch will take keep your data for 15 months. So enabling both real time monitoring and long term trend analysis also it is there. So that's what your monitoring of S3. Now creating of clusters, creating of sorry custom metrics. We can create the custom metrics also. I think just now I spoke about cache hit ratio and all those things. So CloudWatch is emerges whenever you extend beyond standard metrics to capture application specific telemetry. Telemetry means your metrics. For example, business metrics, you can mention in a business what are all things, e-commerce business, let us take what are all the how many number of orders placed, revenue, what generated, how many number of users signed up. Applications health, you can go for like options like failed logins, API, API response time, error rates. Infrastructure, you can able to go with cache hit ratio or connection pool usage or queue depth. These are all the option metrics we can create. Publishing options, we can able to publish from SDK integration. That is your SDK integration for language specific implementation. SDK is nothing but software development kit from your VS Code. If you're doing any project or something, you can able to establish that also. I think you might have done in AWS, like how we configure AS3, EC2, and VPC in In Terraform, you might have created a VPC, right? VPC EC2 instance S3 bucket. Same thing we can able to set for CloudWatch alarms also. That will show it. CLI for scripting and publishing, command line interface. So direct API calls for custom integration also we can do. So CloudWatch agent also will work for server side metrics collections if it's required. That too, it's based on our interest. Custom metrics help enable us to correlate between the infrastructure performance and the business outcome. So how much what is the infrastructure performance, what is the business outcome, and providing contextual insight during the troubleshooting. Contextual insight means what? We are getting an idea of what to do the next step. Okay, now how to push custom metrics. So here you can able to see AWS CloudWatch, put metric data, namespace, metric name, value file, all these things we can able to do it. For this again, like I think you might have written for a Terraform and the other files you might have written the code. Same thing here. We can able to use this namespace. Container for real-time metrics, we can use company or the application name, example production.web app. Avoid using AWS as prefix always because the system should not get confused. Key dimensions, we always go with key value pairs with uniquely identifies metrics. Use dimensions like instance ID, service name, or environment for filtering also. Specify using count. Dimensions means like what you want to monitor, what you want to do, whether the service you want to monitor or the instance ID you want to monitor. In that I want to monitor what units, what specific unit you can say you want to go about count or seconds or bytes or parent etc. For proper visualization and calculation of statistics you can able to use this. So best practice batch multiple metric in a single API to call reduce cost and improve efficiency. CloudWatch charges per metric and API calls. So maximum CloudWatch is free, but in case if you go in depth means it might charge you. I think you might have learned in your cloud practitioner that 5 minutes interval is okay, but every 1 minute, every 1 second you want to hold the entire process, then it might charge. Next, integrated CloudWatch dashboards. Integrated means already something is there, we want to integrate with that one. So that dashboard creation, drag and drop interface for rapid dashboard assembly, support line graphs, mainly line graphs, number widgets, text panels, and heat maps we can able to support. You can mix the metrics from different namespaces and regions in a single view also. That's also possible. Advanced features. So you can create mathematical expressions with metric math and horizontal annotations for threshold values. Set automatic or fixed refresh intervals like 10 s to 15 minutes. Live data model for real-time monitoring also possible. So these are the advanced features. Live real-time data every 15 seconds to 10 seconds to 15 minutes, refresh automatic, and the mathematical expressions, that is calculation based on one dimension to another one, or one metric to another metric. Next, collaborations we can able to take with IAM users, multiple users table also roles in one account, publish dashboard to specific user or publicly publicize also, version dashboards with the source control via cloud formation. So cloud formation, I think we have done it in your Terraform. Cloud formation, we can able to track with cloud formation also. So use dashboard variables to create dynamic dashboards that can filter across. So when we create the dashboard for CloudWatch, you will come to know what all the filter options available. You can able to change that. You can able to use that across all the environment, service, and regions without duplicating wizards. So when we, it's like a wizard which we are going to start. Unified monitoring, build, monitor, scale with confidence. So unify monitoring, consolidated infrastructure. Why we need monitoring? Build, monitor, and scale with confidence. Why we need monitoring is based on the monitoring we can able to build, scale also later. So unify monitoring, that is consolidated infrastructure, application, and business metrics in a single pane of glass for holistic visibility. We can able to keep all the monitoring in one dashboard. Blend default and custom metrics. Blend means all the default metrics we can blend in one phase, combining AWS provider metrics with application specific telemetry to build complete observability. We can able to do it. Next, informed decision making. So why we want to monitor means we want to take some decisions apart from that. So leverage real time dashboards to make data driven scalable. It's not like simply we take decisions based on data, what insight we get, based on that we are going to create the metrics. Fine. So we have come to this conclusion of AWS also. Fine. So tomorrow we'll finish this. We'll start. I think two labs are there. We'll try to finish two together, Prometheus and Grafana. It will take some time. Okay.
Okay.
Yeah. Okay. We'll see you tomorrow at 3 o'clock. Okay, miss.
Okay. Bye.
Okay. Bye.